Solve the following differential equation by using integrating factors. Assume x is greater than 0, c is the constant. How do we do it? Here's the steps from the notes. First, step one, you got to get the y dx all alone, then the y stuff, then the other stuff on the other side. So let's do that. So step number one. So I've got to get the y stuff here and this stuff back over there. So I've got y prime minus y over x equals minus 6 natural log x, right? So I got the y prime alone, got the y stuff, got the other stuff on the other side. Step two, find the integrating factor, mu of x, which is the e to the integral of p of x dx, where p of x is whatever is next to the y. So let me rewrite this y over x as 1 over x times y. Same thing, right? That's still just y over x, but now I can see clearly that this is my p of x function. See how it's what's next to y. So step two then, the mu, the integrating factor, is e to the integral of p of x dx. So that's e to the integral of p of x. The minus here is 1 over x dx, right? It's p of x. And so you know what that is. That's e to the negative natural log of x, right? The integral 1 over x. And now, do you realize that negative in front is really it's a negative 1 power. It's a negative 1, and it'll go up and become the power. So this will become e to the natural log of x to the minus 1. Do you remember that? That's a log property back from pre-calculus. That when you have numbers multiplying the front of a natural log or any log, that number can jump up and become the power. So, okay, why do we want to do that trick? Well, because now these guys will cancel. Once you get the e and the natural log right next to each other with nothing in between, like not a negative 1 or anything, they just cancel each other out. And this just becomes x to the minus 1. So that's my integrating factor. Mu is x to the minus 1, or 1 over x. That's my integrating factor. All right, so on to step 3. Multiply the differential equation by that integrating factor, all three terms. So I go, okay. So now on step 3, I'm going to bring down differential equation, which was y prime minus 1 over xy equals minus 6 natural log x. And then I'm supposed to take this and multiply all three terms by it times. I'll do the 1 over x version. Yeah, why don't I do that? I'll do the 1 over x version. Boom. Times 1 over x times 1 over x times 1 over x. Supposed to multiply all three, both sides of the equation, all three terms by the integrating factor. It's on step 3. And can we clean that up at all? Yeah, I guess that'll become over here on this will be y prime times 1 over x minus 1 over x squared y, right? The x made x squared. Yeah, this side, that's about all we can do, I guess. This is just minus 6 natural log of x times 1 over x. Okay, now step 4 says the left side is the derivative of the product. So write it that way. Write it as the derivative of the integrating factor and the y multiplied, right? Write a ddx on that. Okay, it's a little different. So I'm going to write d dx of what? Of y. And the integrating factor, what was the integrating factor? 1 over x, right? It's right up here. This is my integrating factor. And that'll equal minus 6 natural x times 1 over x. Okay. Now, why is that such a great trick? Because now in step 5, integrate both sides. Final step is going to be a little bit to it, though. Step 5, I'm going to actually now integrate the left side and integrate the right side. And what will happen on the left side is the derivative and the integral will cancel each other out. I'm going to move this over a little bit, so a little bit more room. And I'll probably gonna minus 6 in the front. X times 1 over x dx there. Now on the left side, things are easy pickings on the left side, because on the left side, the integral and the derivative just cancel each other out because they're opposites, right? Integration and differentiation are opposites. Now on the right side, you can't just cancel out the integral. Why? Because there's not a derivative there. You know, they worked on the left because we had an integral and a derivative, so they just canceled out and just dropped down the y times 1 over x. But on the left side, I'm going to have to actually do, on the right side, I'm going to have to actually do the integral because it doesn't cancel out. How do you do this integral? Well, to u sub, you got to let this part be u, whose natural log of x, and then du, what's the derivative of natural log of x? 1 over x dx. So all this is du. This becomes minus 6 integral of u du. And then what's that? Well, there's a 1 power, so add 1 to it, and then divide by 2, huh? So that'll be u squared over 2. And then 2 goes into 6 3 times, so it's minus 3 u squared. And what was u? Natural log of x. So there we go. And don't forget that plus a constant. And this other side is y times 1 over x, right? So we did the integral of the right side with a u sub. Let u be the natural log of x. Then du is 1 over x dx. So we're integrating u du. How do you do that? You add 1 to the power, which is 2, divided by it. So that's u squared over 2. This 2 goes to 6 3 times. And then put back in the u as natural log of x squared. Okay, now last I've got to get y alone, right? That's what they want. They want y alone in the end here. And so what's going to do that for us? Well, I think you know, just multiply by x. Multiply by x, multiply by x. So y alone is minus, I'll put the x right there with the 3. Natural log of x squared plus c times x. Let's go check. Is that the right answer? Minus 3x, natural log of x squared. They wrote it a little differently. This would, if you divide these out, it'd be minus 3x, natural log of x squared. The constant, now you think, well, minus 6x times the constant. And I just have, you might say, well, yeah, but you just have c, but that's the same thing. It's a constant, so it'll work. They will take that answer. And so there we go.